Good morning all. This is part 3 of my look at this Ming MPT-7210A MPPT solar charge controller. And today I'm going to sort of wrap up some of the issues that cropped up in the two previous parts, like can we save the on state so that when you power this thing up it immediately starts charging the battery, and you can. I'll show how that's done. Can you charge an 18-volt battery pack? Well, yes, it appears you can. This 18-volt battery pack pushes up to about 20 volts. The incoming voltage, which is from my pseudo solar panel, my little linear power supply, pulls down to about 12 volts. So that gives the differential that the boost converter needs to boost the 12 up to the 20. So that also works. Also going to be looking at some of the other menus in here. And I'm doing it indoors today because look how well the display shows up when I'm indoors rather than outdoors. And that is despite the fact that, if I remove my camera from its mount, it's looking very Algarve-like outside. The irony. So let's start with, how do you make this thing power up automatically when the solar panel first sees daylight? Well, let's simulate that by disconnecting my pseudo solar panel so that this shuts down. Plug it back in, so the sun's coming up and it immediately turns on, the fan spins up, and when the boost converter kicks in it actually starts charging. So let's have a look. The solar panel has pulled down to about 11 volts. The battery has pushed up because it's got current flowing through it to about 21 volts. We've got 200 milliamps of current flowing. We've got a fairly sustained 4 watts and it's clocking up some amp hours. So how did I set this thing to come on automatically? Well, let's have a look at that. Let's turn this thing off. Okay, so set enables you to set the parameters. Now the first one is the dataset number. These run from 0 to 19. There are 20 datasets, and you can see the floppy disk with the arrow coming out means load from set 0. So if I OK on there, it loads from set 0. If I continue round, I can first set the solar panel voltage. I still don't quite know what that does, but I have done some experiments with that and there are some results there. So I've set that to 12 volts. Okay, let's keep going with set. I've set the maximum battery voltage to 22. I've set the maximum current I want to push into the battery to 0.5 amp because this power supply can't really do much more than that. And now here's the trick. Rather than just pressing set, which takes you to the save icon, let's go around again. Battery voltage, current. When you're on battery current, you long press set and it jumps into the next field. Now this is the time after which the display will blank out. If it's on 0, the display never blanks out. In the manual it kind of hints that that's used for engineering purposes, in other words when you're doing testing. But let's set that to the minimum time, which is 30 seconds, so we can see the display blank out after 30 seconds. Continue on round. I can actually set the capacity of the battery. Now I'm not sure whether that does any more than just make this state of charge icon work accurately or more accurately. I don't actually know. You can also set the total charge time. Again, I'm not sure whether that actually cuts the thing off after the timeout has occurred. I suppose I can test that. You can also set the lock status. Now the lock status is simply that it locks the keys and stops people fiddling about with the keys. They can easily unlock it by just holding OK, but it just provides a bit of defense against people messing about there. And then the final one, and this is the all-important one, you can set the on or off status. So I can have it either off as a default when this thing powers up, or by pressing either of these up and down buttons, on as a default when this thing powers up. And that's how you do it. So now one more press of set, we now get the save icon. Let's save all that stuff. And that is dataset 0 saved. So now if I pull the power and reapply it, it comes on in the on state, unlocked because that's what I set it to, and away it goes and starts charging. Constant current mode, CC there, because it hasn't reached my voltage limit. whatever I set that to. I can't remember now. What was it 22? Was it? Let's have a quick look. Yeah, 22 volts. It's not got the battery up to 22 volts, so it's in constant current. Now, constant current means either current limited by what's available from the solar panel, and there goes my display timer. At the moment, the current available from this pseudo solar panel, my linear power supply, is only about 200 milliamps, so that's the limit. The other constant current limit, of course, is the limit I set in here. I think I set it to about 500 milliamps, so that would also be a limit. It will go into constant voltage if the battery voltage reaches my maximum, which I think I set to 22 volts. It hasn't got there yet, so it's still in constant current. And then, yes, that's going to get annoying, isn't it? And then when the battery voltage hits the maximum voltage, the current will start falling. When the current drops to near zero, this icon changes to OK, and that means the battery is fully charged. Now, there are a couple of other hidden menu items. If, when you're in the off state, you press and hold up arrow, yes, this allows you to change the brightness of the display, which you can go up and down. Oh, that's a bit stroby, so I'll have that nice and bright. And also the speed of the fan. It's kind of, I don't quite know, the fan speed seems a bit wild, but let's have a mid-speed fan. OK, that. So I think that was pressing and holding up arrow. Now if you press and hold down arrow, something weird happens. It kind of puts a row of dots over the current field. Let's do that again. See that row of dots appear over the amps range. And I think what that's doing, I think I read it somewhere, but I can't find it now. It calibrates the zero current. So when zero current is flowing, you do that press and hold, and the current measuring system in here is calibrated to zero. I think that's what it does. Now, thanks to everyone's suggestions in the comments on parts 1 and 2 of this video. Someone suggested, can you use just one 18-volt battery? Well, yes, it seems you can. As long as you have that differential between the input voltage from the solar panel, which when the boost converter kicks in, that solar panel voltage is pulled down a bit. The battery voltage is pulling up, so I've got a nice, 8-volt differential there. And so the boost converter can do its boosting function. So yeah, that seems to work. You can go below that minimum 24-volt battery system requirement. 18 volts works. 12 volts I think would be a bit of a push, because when I tested the voltage at which this unit just falls apart, it was about 8 volts, which makes sense. If the micro and the display are using 5 volts, you need about 3 volts of overhead to keep the electronics running. So below 8 volts, this thing isn't going to operate properly. It probably won't operate reliably at 8 volts anyway. So I think you can pretty much rule out using this charge controller on a 12-volt system. Now you can see this thing's running quite reliably. We've got a consistent 4 watts of power flowing from solar panel to battery. I really must set that display timeout back to 0. Now that is with my solar panel voltage setting, if I go into the settings, at 12 volts. But what does this field actually do? Well, all I know is that if I reduce that to, say, 8 volts, which is, this has got a quite nice wind up and down system. If you press rapidly, it goes up in sort of larger increments. If you press slowly, it goes up in individual increments. Once you get used to it, it's quite good. So let's set that 8 volts, 22 volts on the battery, half an amp. I don't need to go into the second set of fields here, so I can go straight to save. Save that, and now try and run this again. It will do what it was doing yesterday outside. It turns the boost converter on for a while, realizes that there's something not right, and then backs off again. And it does this quite consistently. Boost converter comes on, and it just backed off. So what's it saying? Is it saying I can't get the panel down to 8 volts? Because it can't. So I still don't quite understand this field, but certainly if I set that to 8 volts, the panel can't be pulled down to 8 volts. So it sees that there's something wrong. and it just backs off. On the other hand, if I go into set and wind that up to 12, ooh, that thing does take a bit of getting used to, that fast scan thing. 12 volts, set, and save. Then this thing behaves itself. Turns on the boost converter, pumps 4 watts, and sits there quite happy. So, I don't know. Guesses as to what this field actually is? I've set it for 12 volts. It seems to be achieving 12 volts. Maybe I could set that higher, because this was the other issue. Is this genuine MPPT, or is it just trying to find that voltage that I put in? So let's set that higher to 16 volts or something like that. Let's just try that now. Set, up that to 16 volts. Oh, come on. 16, right. Set, and save. And let's try that. Will it attempt to hold 16 volts? Boost converter hasn't actually switched in yet. Or will it be happy that the panel voltage is quite a way lower than 16 volts, but seems to be happy? The 4 watts power transfer is quite consistent. Panel voltage is down at about 11, 12, 10 even. Display is switched off. So really it seems that that voltage that you put in here must be higher or equal to the maximum power voltage. If you set it lower, there seems to be a problem. But I still don't know what that is. So is this a useful charge controller, given that it has this boost converter topology? Well, yes it is, if you've got a relatively high voltage battery pack. Now, a couple of people suggested golf carts, which have 36 or 48 volt lead acid battery systems. You could charge that battery using this charge controller from a 36 cell panel, nominal sort of 18 volts maximum power voltage, step that up to 36 or 48. So for golf cart use, yes, this would be ideal. It's not so useful if you've got a low voltage battery system, say 12 volts, and you've got solar panels all strung in series to get a nice high voltage and low current because you're using long wires. It can't be used for that, because for that you need a buck converter topology. Now let's just clear up what this lock icon does. If I press and hold OK for a good 2 or 3 seconds, it locks, and now none of the buttons do anything. It's simply a keypad lock. If I press and hold OK again for about 3 seconds, it unlocks, and now buttons, which ones should I do? The set button, for example, these buttons do function. So that is simply a keypad lock, but yes, you can save the off or on status into the parameter memory, I should say. Now, just going back to this thing about how to set these additional parameters, it is in the manual, but it's not very obvious from the printed one. Here, where you're setting the battery charging current, there is this big red arrow, it's grey on here of course, which says long press set, but it doesn't seem to go anywhere. It says turn the next line. And this manual is, for a start, it's printed upside down in the middle. So turn the next line to where? Well, it's actually to here. And yes, it does take you into the settings for the display timeout, the battery capacity, the timer timeout, and the on or off status. There's the lock. There's the on or off status. It's not very obvious from here. Let's look at the Banggood website. It's slightly more obvious here because here where you're on the battery current setting, you've got this big red arrow. Long press set takes you into these additional parameters that you can set, and one of those is this one. Oh yes, I didn't see the sequence of arrows. This one where you set the on or off status. There's off, there's on, and then you go to save. And so you can save that on or off status in the parameter set. So So it is in there, it's just a bit tricky to fathom it out from these instructions. And finally, one or possibly two commenters said, can we have a more detailed look at the circuit board in here? So yes, I'm going to disconnect all this, open this up, and we'll just take a look at some of the components on the board. Right, here it is out of the box. Now I'm also going to disconnect these two connectors. Got to try and remember which order they are. Oh, well, they're in line with each other, so that makes fairly obvious sense. Let's take those out. That's the display and keypad. You can see the display soldered onto there. Not quite sure how they've implemented these keys, but they're obviously these tactile sort of dome things that spring one way and the other. Right, let's get in a bit closer and have a look at this circuit board. So let's look at the obvious things first. A big inductor here. Now we saw that the solar panel input goes straight to the inductor, or at least I think that's what happened. Yeah, the solar panel positive straight onto the inductor. Then the inductor comes down to the diode. This is the diode. I can't quite see that number. I'll come back to that in a minute possibly. There's a MOSFET here. So those are both on this heatsink, and the fan of course blows air through that heatsink. There are a couple of other MOSFETs. There's one down here, that's an 045N10. There's another MOSFET here which is a different number. I can't remember what the number is. I did look it up. I think it's higher voltage or something like that. Let's look at these capacitors. These two are on the output. They're rated at 100 volts. Now we know from the menu system that the output can be up to 90 volts. The input capacitor is only rated 63. You can see it down there, even though that setting for the solar panel voltage does actually go up to 90 volts. If you put a 90 volt solar panel on this, or one that can produce an open circuit voltage of 90 volts, you could pop that possibly. So it's worth noting that the input capacitor is 63 volts. What have we got? Some sort of regulator there. This is the CPU. It's an ST microcontroller. I don't think it matters really the exact part number of that. There's a crystal. What's the frequency of that? 16 megahertz. Various 8-pin devices here. They're probably op amps to measure current on these current measuring resistors. Now there are two of these, which is interesting. There's one here, and there's also another one here. So is it measuring both the battery current and the solar panel current? It only shows on the display the battery current, but does it use perhaps the current flowing from the solar panel internally somehow? That's interesting that it's got those two resistors, and yet there's only one current measurement actually visible on the display. Now what else have we got? Well, there's a little inductor there and a chip. So this is probably a little buck converter to take the voltage from the solar panel, which could be, well, anything up to 90 volts according to the menu system, but anything up to 63 volts according to that capacitor, to take that and to regulate it down to something that the CPU can use. Possibly it regulates it down switch mode first and then linearly afterwards, perhaps. I don't know. I'm not even sure that that's a regulator. There's another 3-terminal device there which looks more like a regulator. What we got? Big resistor there, low value presumably. And that's about it, I think. Okay, let's do a little close-up on the microcontroller. STM8S00, whatever that says. And these devices here are 272, so what's that? TLO 272? I don't know. These are probably op amps. That one looks a bit different. Can't quite make out what that is. 3845B or something. What's this regulator? Yeah, that's definitely a regulator. It's AMS 1117. What's this device? A 60T03. Is that a MOSFET? That might be a MOSFET. Actually, it might even be the fan MOSFET. It's right next to the fan connector. Maybe that's pulse width modulated from the CPU to control fan speed, something like that. Okay, these two devices on the heatsink, that's an 045N10N, so that's an N-channel MOSFET. This is the diode. It's an STP, something, I can't quite read it, but you can see when you flip it over that the two outer connections are commoned. So it's a double diode that's been just paralleled up. Right, this other MOSFET here I need a torch for, but it's an SSF7509 Silkron, I think it says, is the make. Let's look at the buck converter chip down there, if indeed that's what it is. Oh yeah, that's an XL Semi XL7005, is that? Yes, I think it is. So that's most likely the buck converter to provide low voltage to the CPU and display. Interesting device here near that MOSFET. It's 4-pin. It's probably an opto-isolator to drive that MOSFET because it's at some different voltage level or something like that. It's an EL357N, I believe, and then the thing below is probably the date. It looks like there's a programming header up here with lots of lines running down to the CPU. So that's got to be T for transmit, R for receive, ground, VCC probably, and F. Not quite sure what F would be. So yeah, that's the circuit board in this little MPPT solar charge controller. Fairly typically Ming. It's got this sort of leaded tracks on the bottom to provide a bit of extra current, very similar to one of their other products. This is their digitally controlled boost converter, very similar sort of layout and design on the back. Interestingly, no stickers or markings on there, but then that's perhaps because they're on the case, on the outside of the case, and they don't need to be on here. This is effectively the outside of this product. So to sum up, if you're looking for a charge controller with MPPT for a high voltage battery system, a battery system of at least 24 volts, then this perhaps is the product for you because of its boost converter technology. If you've got a low voltage battery system, a 12 volt battery system, and you want solar panels of I don't know, anything from 18 upwards, then this isn't going to be any good, and you want a system that uses a buck converter topology. I do believe that this is genuine MPPT. I'm just trying to put the fan connector back on here, because although it has this field where you program in the solar panel voltage, it doesn't seem to. It does seem to hold the solar panel at a voltage not necessarily the same as the one that you set in the menu. So I do believe that it is using some sort of tracking algorithm to find and hold the maximum power point. Certainly it has battery wattage, battery power as one of the parameters. So maybe it's maximizing, rather than maximizing the solar panel wattage by measuring solar panel volts and amps, it appears to be maximizing the battery wattage, which amounts to the same thing, I suppose, by maximizing watts flowing into the battery. And I just have a general trust of Ming products. I've got a lot of the Ming DC to DC converters, both the buck and the boost. I think they do a buck boost. I don't think I've got that. That might be one I need to invest in. But yeah, I think I trust Ming to produce something that's not a scam. I mean, it certainly is doing DC to DC conversion, and therefore it is capable of doing MPPT, unlike some of the other fake MPPT charge controllers I've looked at, one of which had a 555 in it, I think, and the other one didn't even have an inductor, so there was no way it could do the voltage conversion necessary for MPPT. But yeah, I think this one is probably the real deal. It's just this issue with the boost converter topology that you need to make your decision on. So the question is, should your solar charge controller, your MPPT solar charge controller, use a boost or a buck topology? Which is better? Well, maybe there's another way. Bit of a quick post bag here, because this is one that I've not opened to date. Maybe this is the answer. Oh, that's quite neat. That's a lot smaller than I thought it was going to be. This is the LTC-3780. I'll just get in a bit closer. Yeah, this little chip, the LTC-3780, is a buck boost converter chip, which uses an interesting topology. It uses 4 N-channel MOSFETs, which are stuck under these heat sinks, to produce a synchronous, so there's no diode here, it's all done with MOSFETs, buck boost converter, so the input can be greater or less than the output. Now, wouldn't it be great if Ming He, if you're listening, Ming He, somehow managed to incorporate this topology, which is buck boost, into an MPPT solar charge controller, and even into their other digital boost and buck converter products. Because with something like this, you could have solar panels that were both, either a higher voltage than your battery system, or solar panels which were a lower voltage than your battery system, and you wouldn't have the limitations of a fixed topology, either boost or buck. This is buck boost. So I think that wraps up my first look at the Ming He MPT-7210A. Big thanks to Banggood.com who sent me this. I'm not quite sure where I'm going to use this, or if I could even use this in my own system. Well, I can't because it's a 12-volt battery system. But I was toying a while back with the idea of buying a very cheap electric car. It's called the G-Wiz in the UK. It's made by Riva, which is an Indian company, and it has a 72-volt lead-acid battery system. Well, now this device could be used to charge a 72-volt battery pack. So maybe one day this will get used, but for the moment, that's it. Cheerio.